let's continue. I will save this to 03. Then in the 02, we have made this one. So if you come to this angle, actually you can click this to come to this angle directly. So you can put that different. But to myself is I like is I put this. I see. So which one? We put those. How to back to the default? Reset view. No, this is the default XYZ. Then you can. I used to just use my mouse to change that. And we finished to here, and we have used twist parameter within this linear, the extrude, and by default, and we also have this convexity is the auxiliary parameter, ensure that the preview of the geometry is calculated cleanly and has no hole. So when we twist, there's no hole inside. By default, the value is 1, and normally we put 10. So that's another explanation. Now for this continue, we will describe the tapered shape of the fan blade using balloon. Excuse me. So we have our blade already, and we will continue to do this. Square is our blade, and we have an angle, inner, out. So we're starting to build some more parameter. And the difference of our linear, this is our blade base from this, and delete this inner head, rotate, what it will get. So we will delete this by a cube, this one and this one, and then we get this the left things. So now our blade is here. Looks like we will remove this part, remove this part. So let's have a look. So if we want to do this depth height, we need to build this. So cube. So let's starting from this one. So we have this. I want a cube width times 2, depth times 1.5. Just to make this cube is resize. Time, height. Now we need this 3 parameter. We define from here. So height is let's just do this width, depth, height. So let's starting from depth. Depth is outer width divided by 2 minus inner height width divided by 2. So now we can remove one arrow. So we got this one, but there's nothing for now. So we define depth. Depth is we will use outer width with twist, inner width, then blade height, plus thickness. So let's see, we have square plus thickness. So square power the width divided by 2 times cosine ABS. ABS to get the absolute value twist. If twist, because we have this minus 30, ABS of twist is just positive 30, and minus by inner weights divided by 2, and power is 2, then plus power plate height so we should further remove the missing pyramid. We just have this height. Height is a sine ABS. So again, we use a twist ABS times outer width divided by 2 plus thickness. So we have all this perimeter, so we can make our cube. But with this cube, if we see here, we need to rotate, and we need 2. So then we have the started, and we need an angle. So when we rotate, we rotate an angle. So first we will do the translate to our cube. So we make this translation, and we will start to do this rotate. And for the rotate, we need to define our angle. Angle is a new formula. Is anti-tan. So we have this outer width divided by 2 times cosine. So it's the same as here, cosine ABS. Twist. Minus inner weights divided by 2 divided by blade height. Now we have the angle, we can start to do the rotate here. Rotate on X, XL is 0, Y axis 0, so just rotate minus angle for Z, XL. So it's like this, but looks like it's our Y, they give us this translate. So translate depth divided by 2 is move to this direction, but looks like here is no. So if we don't have this, looks like this is here, but possible this depth times 1.5 minus depth. Depth is here. Is this one? We double check whether it's too big. Inner power plus power blade height. This is the square, and then plus thickness. So this depth is correct, but looks like it's translate too far. let's follow the author. And because we have another translate we haven't done, so let's try to understand this translate. Translate inner, so on X, so now X is here. X is this part, and then Y is here. So now it's move to here. So let's do this translate. First, if we just try to understand the effect, if you do nothing, translate is all 0, 0. So let's see. So we also need to go to some the Z. So first, let's make this Z is the negative. So it's go to something down. That's correct. And let's make, then we go to X. X is inner width divided by 2. Here, good. And then now we can shift on Y. Inner height. Perfect. So it's not actually from the origin point. So, but it's perfectly cut all our blade here. That is one, and we need another square. So let's copy this to the second square. So now that's the same, but first this square is the size is the same. The second cube, we don't have the second cube. Okay, so this one we don't need to do the duplicate. We have a for loop. This for loop is for I, then I is 0 or 1, so we will do a mirror. So if we have our mirror, if we say here is 1, 0, 0, 0, then there's nothing. But if I want this mirror based on X, then they will get this one. And then we need both, so we'll give I, and we put everything is inside a for loop. For I equal to 0 to 1. By default step is 1, and then we have both. No, so that's very smart. And what we are going to do is we will use a difference from this blade to remove these two cube. Then we just left the bottom, the middle one. So we're adding our difference. So this difference is first is our blade, then second is this mirrored cube. So after that we give our this. No, we have that. And if we want to have this to be showed, is like this. So that is the thing is we can make this happen. Cut off the edge side parts using balloon. Difference result in jagged egg. So let me close that. Let's see what's the difference we have. No, now very good. We have our single the blade. We will continue in next video to talk about further the blade shape. Thank you for watching.